Hello and welcome to week 5 of the intermediate year 6 into 7 Emmbrook School maths program. Same format as every week now. I think we're getting pretty used to this. So you've got 10 questions that you can see there on the screen. So have a go at those and pause the video, and then I'll flick to the answers in a second. If you get all the answers right, well done. Then maybe have a go at the advanced video. If not, flick through the video to see if you can find if my answers are any use to you at all. I'll cross them off as I go. So if you want to pause now, I'll go through to the answers. So here are our answers then. So again, like I said, tick them if you've got them right. Go back and check, see if you can find where you went wrong, if you went wrong. Let's proceed then to go through them. So for question 1, nice addition just to warm ourselves up here. So let's pick ourselves a nice pen. So we've got 463, add 354. So only things to watch out for here is, have I got everything in the right column, units, tens and hundreds? Am I going to carry correctly? Going to think about that if it occurs. So let's get going then. So 3 add 4 is 7, 6 add 5 is 11, let's carry that 10 over, and then 4 add 3 is 7, and one more to get us our 817. Okay, so we looked at fractions in previous weeks for question 2. So what is 1/10? It's really useful to say it because it doesn't look like it makes what is 1 over 10 of 250 doesn't really make any sense. So we say what's a tenth of 250. So a tenth of something is a quantity broken up into 10 equal bits. And break up in terms of maths, a mathematical operation just means divide. So really all this means is something that you probably know how to do for ages, 250 divided by 10. Okay, to break it up into 10 equal bits. So 250 divided by 10 is just 25, because if we divide something by 10, we can just move all of the digits one place to the right in the columns, and we end up with 25. Okay. For question 3 then, what's 4:15 p.m. the 24-hour clock time? So something that you're probably familiar with if you've got it set up on your phone. So we've got a clock phase. At midnight, we start at 12 a.m. and then we go 1 a.m., 2 a.m., 3 a.m. So these all mean in the morning. Until we get through, in the middle of it, until we get through to 12 p.m., which some of you might have as your lunch time. And in the 24-hour clock, we just mean how many hours after midnight have we proceeded through the day. So if we get to 12 p.m., that's 12 hours since midnight. And then 1 o'clock in the afternoon is 13 hours since midnight. Okay. So we've got 4 o'clock in the afternoon. We want to be 4 hours past 12. So 2, 3, and 4. So you can just add that 4 onto your 12, because this would be 13, 14, 15, and 16 hours since midnight. So in a 24-hour clock, it would be 16, 15. The minutes don't change. Okay, so that's just how many minutes there are past that hour. Right. For question 4, count down from 125 multiple to 25. Okay. You can actually cheat here a little bit. Because it's in multiples of 25, if you find it easier to count up to 125, then you get familiar with the 25 times tables. Okay, so counting down, we start at 125. If you really needed to, you could just subtract 25. Okay, so you could do 125 and then take away 25. But hopefully you quickly see that, oh, that will just lose me all of my tens and all of my units, which will just leave me with 100. Okay, now I'm going to take away that 25. That takes me down to 75. Again, if you need to, go to a column method. Whatever it needs to get there, just do it. I've got 72, haven't I? 75. Take away another 25. So again, this should be quite easy to do in our heads. So take away 5 from the units, we get 0, and 2 from the tens, we get down to 50. Okay, and then 25, and then 0. Okay. It does say 20 there, it didn't put it in the answers. Just to be clear, 0 isn't a multiple of 25. These ones would be the multiples, but we have counted down in multiples apart from that last one there, really. Okay, question 5. So again, the only thing we need to really be looking for in these subtractions is just lining up our thousands, hundreds, tens, and units correctly. So we've got 5,630. And then we'd like to take away 2,780. There we go. Okay, so no units to take away from one another. Now I've got 3 tens, and I'd like to take away 8 tens. I can't do that. Okay, so I need to borrow from the hundreds. So that's going to go down to 5 hundredths. And I'm going to pop that onto my 3 tens, and we just now represent 130. So it'll be 13 take away 8. That gives me 5. You can kind of, it's quite nice when you've got zeros there. You can see what calculation you really did, which was 130 take away 80 there. That's what really happens when you borrow. 5 take away 7 can't do. We'll go into thousands column and borrow 1,000. Pop it onto here. So now we've got 15 take away 7, or 1,500 take away 700. Which takes it down to 800. Okay, and finally 4 take away 2 is 2. So we've got 2,850. Okay, so for question 6, we looked at lines of symmetry before, and if you remember it, if I were to draw a line through the shape, what I would see on both sides of the shape should be exactly the same if I was to look into a mirror. Okay, so for instance, if I was to place a mirror here, and I'm going to put myself here, there we go, what should I expect to see in my mirror? Well, I'd expect to see exactly the same thing. So a line coming in and coming back out to that point. And it would look something a bit wider, overnight, like that. And then I would be here. My feet weirdly are closest to the mirror, so I can see myself like this. Okay. But as we can see, this, what I've drawn here, is not an exact replica of what we've got here. Okay. So the only line of symmetry for the trapezium actually looks like an isosceles trapezium, which means these two angles and these two lengths here are the same, is down the middle. Okay, so this line maps this one then goes away, as does this one, and they come back here and meet. So this side here is identical to this side here if I reflect that over the mirror line. Okay, so one line of symmetry for that one. Multiply 3.6 by 10. Hopefully lots of you are just doing that in your heads now, but just in case, so we've got our units and tenths columns. So I've got 3.6. If I want to multiply by 10, everything's going to get 10 times bigger. So we're going to move one place to the left in our columns here. So the 3 is going to go into the tens, and the 6 from the tenths is going to go into the units, and we're going to end up with 36 there. Okay, so you can probably visualize that shift over now. Right, for question 8 then, 1,200 seconds is how many minutes? Okay, so again, let's make sure we have all the information at hand before we start this one. So we want to know that 1 minute, 1 minute is equal to 60 seconds. Okay, and if we think about a ratio, you could have it rather than an equality here. You can have it a ratio for every 1 minute I get 60 seconds. What I'd like to know is if I was to put 1,200 seconds here, or 1,200 seconds, how many times bigger has this quantity gotten? And therefore, how many times bigger does this quantity need to become? So, how many times is 60 going to 1,200? So I want to do 1,200 divided by 60. Now, some methods that we saw last week, and I've used in other videos, is I could write this and simplify a fraction if we're not sure. Okay, so you just have the answer to this. So this is the same as this, 1,200 over 60. Okay, so let's figure this one out. So I could simplify this fraction, divide it by 10. So that becomes 120 over 6. I'm just going to go to the next video now.